Welcome to the April 3rd, 2024 SIG API Cloud Provider, SIG Cloud Provider Network Proxy meeting. This is part of the CNCF, and as such, we are beholden to follow all of their rules, most of which amount to please be respectful of one another, give each other the benefit of the doubt, and please be polite. With that, I'm going to go ahead and kick off. So let's go ahead and share. All right, so present today, myself, we've got Jay Parrell from Red Hat, Weiling from Apple. Please excuse me if I'm messing up any of the pronunciations, and Mayak. I'm not seeing much of an agenda. So I have a few things I'm happy to chat about, but before I go, we have some new folks, and we also who may have things they'd like to discuss. So did anyone have anything they wanted to chat about? All right. So let's. All right, so if I bring up our repo, let's start here. Sorry, I should be more organized. All right. So Joseph has a proposal to go to 121. To those who aren't aware, actually, since we have new folks here, one thing that is worth understanding about this repo, sorry, I'm going to switch to the code tab, is that you'll notice that we have most of this, and then we have connectivity client. And so we have things like the go mod at the root directory, but we also have a go mod at the connectivity client directory. So the rest of the code depends on connectivity client, but the Kube API server also depends on connectivity client, and we need to be able to support the oldest version of the Kube API server without actually forcing upgrades of dependencies and that kind of thing. So when we start talking about things such as Joseph's upgrade to 121, it's okay for the root go mod to be at 121 or whatever version we want, as long as we're making sure to take care of things like CVEs. But we want to try to keep the go mod at connectivity client to be the same as the oldest version, supported version of Kubernetes, so that we're not introducing upgrades to them. So I'm assuming Joseph knows this, I'm sure. So I'm assuming he's doing that. So I haven't actually reviewed this yet. It looks like he opened it just recently. All right, proxy strategies. So I know Joseph's in the process of doing the proxy strategy cleanup. Would it be worthwhile for folks if I go over how proxy strategies work? All right, not really hearing a response. I'll go over it briefly, since I've got neither a yay nor a nay. Okay, so proxy strategies have to do with how traffic gets sent. So very brief bit of history. Before we had the network proxy, we had something called SSH tunnels. The way SSH tunnels worked, and I think Google may have been just about the only one who actually used SSH tunnels back when that was actually part of Kubernetes. There would be an SSH client that would be on the nodes. The Kube API server would SSH out to the API, to the SSH daemon running on each node. And then when it needed to send a request into the cluster itself, it would just connect to that agent, or it would connect to a random agent and dump traffic. So the idea behind this is that when we got rid of SSH and replaced it with network proxy, we actually have a connectivity client that is running on some or all of the nodes, and they connect back and establish the tunnel. And so we need to determine which is the best tunnel to send traffic down. The very first version of network proxy mirrored SSH tunnels in that it would just pick a random agent and send traffic irrespective of where that was destined. Now, there are some interesting cases like TNA, which is sort of an edge cluster device for telephony, where there isn't actually connectivity between the various nodes, so you can't randomly route traffic. So what agents in telephony do is they advertise something that tells you what kind of traffic they will handle, which node or which IP address range. And so you can set up your, what we call your strategies, to say, I only want to go to I only want to connect and send traffic to an agent that is advertising the same, whatever the strategy mechanism is, whether it's like IP address or host name or whatever it happens to be. And so with the strategies, the default strategy is just randomly pick. There's some strategies that are more, and you can actually comma separate when you're starting up the network server or connectivity server, which strategies it would like to apply in what order. So there is actually a strategy called the default strategy, which is the random. So if you wanted to say, I want to try to go exact first, and if you can't find an exact match, then random, it would be, IPv6, comma, default. If you wanted to do exact and return an error, if you couldn't get an exact match, you just put IPv6. So that is the mechanism that we're talking about with proxy strategies. Joseph wants to improve the test coverage, and he has some ideas for some code cleanup. Looks like he wants to do something with the default backend storage. We've got a bump the GoMod dependencies. I need to look at this. We've been having some problems recently with Go. So we've got Dependabot automatically upgrading, and the last few times I've looked, the GoMod dependencies has had a test failure that I've been trying to dig into, but yeah. Agent drain. So this is another interesting one, and this is definitely, I think this is the one I was hoping to get to. I think it's worth having a chat with everyone on how agent drain should work. Joseph has a proposal. It's a pretty good proposal. So the idea on agent drain is that today, when you want to restart an agent, maybe you need to upgrade it, whatever happens to be going on, you send it a kill signal and it immediately dies, taking any connections that were in it away. So the thought process is, rather than immediately killing it, it would be nice if you could essentially say, it's going to notify all of the servers that's connected through some sort of side channel to say, hey, I'm going away. You have a limited amount of time. And that would then do something like go to that strategies and maybe either remove or at least downgrade the agent in the strategies. So there's sort of a few things to think about there. One is the new connections. So most connections for things like webhook calls, fairly short-lived. So this would certainly give you the ability for the agent to say, hey, stop sending me new traffic unless you absolutely have to. And then all of the short-lived connections for things like webhooks would presumably get finished, and then new connections would get sent to all of the other agents unless this was the only agent left. What it won't fix, just so we're all clear, is if you do something like you say kubectl proxy, and that happens to be going through an agent, and that may be a request that's going for hours, because it's just, you know, the whole point of proxy is to set up a tunnel and get all the traffic. That's going to get failed, and that won't. So this drain isn't going to help that sort of very long-lived connection, but it will certainly help with things like all the webhooks and minimizing any problems caused by webhook. So there are some edge cases that we want to talk with folks about, or Joseph wants to talk. Unfortunately, it looks like he's not here today, but I think he has a proposal in here if folks have opinions. But a lot of it comes down to what we do with those edge cases. Like, what if there is only one agent? How long should we wait before, you know, if there are existing, like, would it make sense if you get to 0 connections to quickly kill yourself or have the agent quickly kill itself at that point? Or does it make sense to wait out whatever we decide is the right time period? I think it's 30 seconds is the default. So I don't know if anyone has opinions, thoughts.
It's possible to have a long-term connection to a webhook, or it will absolutely respond immediately?
So I'm not sure of any cases of a long-term connection to a webhook, but so Proxy is a special command for kubectl and the kube API server, which basically says, I would like a permanent tunnel to be created between my laptop and the cluster, so that I can send traffic to the cluster like I was in the cluster. And so that is absolutely a long-lived connection. There are probably a few others. I think, for instance, if you did something like a kubectl logs-wait, that again, you connect to the API server. The API server connects to the relevant node, and then it's basically just reading from the node permanently until you kill that tunnel. So those are the primary things I can think of that are long-lived connections.
Yeah, the port forward also, I think. Kubectl port forward.
Yeah. Now with webhooks should be fast, but a lot of it depends on things like how backloaded the webhook is. So for some webhooks, Gatekeeper would be the primary one I can think of. If Gatekeeper's under a lot of load, it uses KubeBuilder, and KubeBuilder has agent-side throttling. So when Gatekeeper's under enough load, KubeBuilder can cause some Gatekeeper requests to take 2, 5, 10 seconds, which doesn't seem like a lot. I mean, it's actually a lot for the webhook system, but that doesn't seem like a lot for us, but that's a pretty long-lived connection when you're talking about this sort of thing. And if the system's that badly backed up, having 20% of the webhook requests all suddenly failed is going to produce some interesting effects. And I don't mean interesting in a good way.
Yeah. All right. No, I just was thinking on the proposal from him, but the only concern that I could have is that one. Maybe some kind of long life connection gets stuck or something with a timeout. It applies a timeout and the agent connectivity gets down.
Yeah, I mean, I think at some point there has to be a hard limit to how long you're willing to wait, and sometimes connections have to be broken.
yeah, totally. All right, cool.
All right, and then I will also mention one that is I'm I haven't actually done too much on, but I keep thinking we should do. Whether it's Google or Microsoft or Amazon or whatever your cloud happens to be, most of us have something that amounts to what in Google we call regions. In Kubernetes, we refer to them as failure zones. And so for most of us, there is, if the default strategy is is just the default random, that means some percentage of the time you're going to be sending traffic to failure zone A, and then the routing system inside the cluster is going to have to go and send your traffic to failure zone B. And sometimes there are things like charges. There's definitely latency involved with switching regions. So one thing that I keep thinking it would be nice to do is to have the agents advertise the failure zone they're in, and then have the system smart enough to have a strategy, which is to at least pick a random agent from the correct failure zone. So that way it would automatically prioritize. So you could have, failure zone aware and then default. So as long as there was at least one agent in the right failure zone, the connectivity server would establish a tunnel to the right failure zone, thereby reducing latency from doing region ops. So I keep thinking we should go ahead and build that. I don't know. I've been doing way too much talking. Did anyone else have any topics they wanted to go over?
No, regarding the last topic you mentioned, the best route for the failure zone. If we have some kind of evaluator which calculates the best route to the failure zone to send that traffic, we should have the capability also to avoid a concrete zone in purpose. I mean, go to the failure zone, whatever. Just in case, I don't know. We know we don't want to send that traffic to that zone because business reasons. I think and the evaluator should have that capability at least to catch the best, but you can select what you want.
So I like the idea. I'm trying to think of practically how to do it. So if you don't mind, let's go ahead and chat on it. So I mean, generally this would be we would try to do this as a strategy, and I'm not sure I quite see how to do it as a strategy, but let's keep talking because maybe we can find a way. So we have a strategy, which is your avoidance strategy. When a request comes, so when the API server sends a request saying, hey, please connect here, what I'm trying to work out what you would know that would allow you to know which agents to avoid.
Yeah.
I mean, so this is sort of like an allow list, deny list problem, and I think at some level we've sort of built this as an allow system or a match system rather than a not match system. But that doesn't mean we can't do it. I'm just trying to think. I'm trying to think how we would do a not match. I mean, obviously you can have a strategy that is not match.
Maybe not allow the best one when it's not selected, or I don't know. It's a weird. Yeah.
Do you have a concrete case that you can talk about? I mean, I think sometimes that makes it a little easier.
No.
Okay.
I was thinking just in if you select by evaluating the best route with the number of hopes until you reach your destination. The best route will appear eventually, and if not, you will hit a random. With a random route, you will have the route initially, so that's not an issue. But if you have an issue with that zone for whatever, I don't know, but yeah, it's it's just on my mind. There's not any use case. Yeah.
I think it's a great one. So so if we take the latency, so there's two things you mentioned. One is latency and one is hops. I think the interesting hops seem like, maybe we reevaluate hops periodically. I think the interesting thing on latency is you could potentially at least have a latency aware strategy that is basically monitoring what the latency was to each agent, and actually basically gives you I don't think you'd want to do strictly prioritized lists, but what you could do is sort of like some sort of weighted random based on the relative latency. So that's actually a pretty interesting idea. I like it. Nice.
Cool.
Yeah, that's pretty cool. All right. Yeah, the only weird thing about that one is I wonder if it would almost be better to do that in conjunction with some of the others, because as an example, I think that would be a really nice addition to something like the failure zone, because you could certainly see that latency works better if you're at least in the right, if you know what the right failure zone is, right? So it may be that the hop across failure zones is more expensive than anything else that it's being done, but maybe what you're doing is discovering that most of your traffic goes to a particular failure zone, and if most of your traffic goes to failure zone A and you have a request for failure zone B, sending to failure zone A isn't actually going to help.
Mm-hmm.
Whereas if you know by failure zone and then are paying attention to the latency, I think you're going to get better results. But that's an interesting thought. Yeah. All right, I like it.
Cool.
Mayank, I'm sorry if I'm saying your name wrong. Hello.
Yeah.
How are you doing? Anything you wanted to chat about?
Nothing in particular. Like I just joined the project. Met Imran once. Like I too am from Microsoft. I felt that project is interesting, so I just thinking about all the stuff that is going on in this project. So. Right.
Awesome. Well, there's plenty to do. If you feel like getting some code done, let us know. I'm sure we can find you something that will match your interests. But
Sure.
just let us know.
Sure. Like this conversation has been interesting. Just finding places where I could contribute. I will speak up once I have something.
Yep. Sounds good. How about you? I'm sorry if I pronounced the name wrong. Is it Wei Ling?
Yes.
How are you doing?
Yeah, good. So yeah, nice to hear all this corner and related update from your expertise team. And I try to evaluate a little bit on that and doing a little bit scale testing on the connectivity or the new name of this product. I see that there is a little bit slowdown if I launch tons of the logs from the server to make sure that some of the important, like a webhook connection, will not shut down because of user dump large line of logs. So do you have any thought on that? Because we rely on this connectivity channel for both the debug log as well as some webhook services going through this channel.
I do actually. So history, everything always comes down to history. The original version of this was going to be gRPC the whole way. Community pushed back a little bit. It's actually a member of Google who pushed back, who has since apologized. But they wanted something that was more open source is probably the wrong word. And they wanted something that was sort of more of a standard. And they managed to convince the community that the very first connection between, or type of supported connection between API server and the connectivity server should be HTTP Connect. One of the problems with HTTP Connect is it doesn't really support connection reuse or muxing. So when we originally built this, we had built it to be able to mux and to reuse connections, all the rest of it. And we had to tear that out. And when we put in the HTTP Connect that people were asking for. Now, the funny thing is I think almost no one, maybe IBM uses HTTP Connect. No one else does. The problem then is that when we went and implemented gRPC, which is what most of us use, we didn't put, like, because we were trying to keep things consistent between HTTP Connect and the gRPC, we didn't really spend the time to get agent reuse and muxing going. So this means that every webhook call from the API server involves establishing a new connection between the API server and the connectivity server, and we're not getting any reuse on that tunnel segment. So it's not the only slowdown, but my opinion is that's probably the easiest and cheapest way to cut down on both the latency and the improve the scalability would be to make that tunnel segment like reusable and be able to handle multiple segments of traffic on it. And the funny thing is we do this between the connectivity server and the connectivity agent. There is one tunnel segment between each connectivity server and connectivity agent pair. And we just mux traffic over it and we never have to reestablish that. And so I think that model, if we were to pull that back and use it between the API server and the connectivity server, that would significantly improve latency and scaling.
Okay, yeah, interesting. So let me get a little more deep on that, and we can discuss more on that.
Okay. Yeah.
Is there some plan we are going to enhance that, or is it still a discussion?
Great question. I'm wondering if we have ever made that actually a permanent. Sorry, I'm just quickly going through so we have it is certainly something I probably other people as well have filed as an enhancement request, but also This is open source. So having it filed, it has to be high enough on someone's to-do list for it to actually happen.
Okay.
No, that's the backwards. All right, done. No. All right. It's probably in the close. So we do have things that get lifecycle frozen and closed. So my guess is it's lifecycle frozen and has been closed out. I can try to find it later, but yeah, I mean, This has actually been one of those things on my mind for quite a while. I keep thinking that it would be nice to do it, and then I get a new project to do at work, and it never quite seems to get done.
Okay.
But
Yeah.
I would
let me
happily
get.
chat with folks about it.
Yeah, we want to make sure our traffic is more kind of reliable, especially for webhook traffic. Sometimes it will block a lot of things. Log and debug can be lower priority. But sometimes we have no control on the quantity of logs they dumped from the pods. Yeah, let me take a look on that as well.
That sounds good. I know I'm suggesting someone else's solution as well, but one thing I would mention that may be worth looking at for this is, are you familiar with the API machinery cell effort?
No.
All right, so cell is spelled C-E-L. So depending on what you're trying to do with a webhook, there is a thing, there's a Google inspired language which the API machinery team has picked up called Cell. And the idea is that a certain number of webhook calls, if you meet the Cell requirements, so it's not all webhook calls, but a certain number of webhook calls can actually be replaced by Cell rules, which you put into your API, so into the CRD. Usually this would be something like a CRD. There may be other cases you can do it as well. And the idea then is that the API server can run the logic locally without ever having to make the webhook call. And so the goal is to just cut down on the total number of webhook calls that need to be made.
Yeah, but this is beyond my control. The customer, may use their webhook.
Sure.
Yeah. So we have to find let me get into more kind of our channel things and see, our end is handle some of these things better.
The other thing I will mention is, and you don't have to tell me your use case or anything, I will point out, I mean, the customer angle is totally valid, but there are some interesting versions of this. So for instance, Gatekeeper is actually in the process of working out how to dynamically convert certain rules that people have written in Gatekeeper into Cell rules, so that they can shift them left onto the API server and cut down on the total number of Gatekeeper webhook calls that need to be made.
Okay.
So I know the OPA community, especially under Max Smythe, has been spending quite a bit of time working out how to do that. So just a thought. There may be, and maybe the right answer is doing some combination of these. So yeah, totally. Please help us work out how to solve this. That would be great. But I also want to just make you aware that there may be some other things to look at as well.
Sure.
Awesome. All right. If that's all, then I think we can call it here. Awesome. Thanks, everyone.
Thank you.
Bye.
Thank you, folks. Bye.